All right, in section 5.7, we're going to learn what's referred to as the binomial theorem. And when you have a binomial, of course, binomial means you have two terms. So if you have the addition or subtraction of two terms to a power, then what we're going to do is learn how to expand that. Now, like something that you're accustomed to seeing, like as far as a binomial, and this is not something you have to write down that I'm fixing to show you, but like if you had x plus 2, say to the second power. Of course, what you've always done, like in a situation like this, is you just write it down twice and you FOIL it out. And when you FOIL it out and combine your like terms, then this is what you would end up with. So as long as it's a second power, it's really easy just to write it down 2 times. I mean, even if you had a third power, you know, you would have to write it down 3 times. And there's already been some times that we've even had to do 3 of them. You know, like you would say start with the first 2. You could FOIL out the first 2, get that answer, and then multiply it with the third one, you know, to get what would be your binomial over here. Or not your binomial, but to get your polynomial. But once you start getting into some larger powers, you know, like a 5th power or a 7th power, then having to write down that many parentheses and do all that multiplying is extremely time consuming. So there is a theorem on how you can do this a little bit quicker. And this is going to be like your pattern that you're going to follow. Of course, I'll explain what all this means. And you're also going to use what's called Pascal's triangle. And some of this information you will actually be given on the test. You will not have to memorize. So actually this, I'm going to have that provided for you to go by. And then I'm also going to give you, like I said, Pascal's triangle. Okay. Now here's what you need to know about how this works. Of course, the exponent's referred to as n, and if you notice, there's some places in here where we have an n that is used, okay? So whatever your exponent is, that is n. The p's that you have, the p sub 0, p sub 1, p sub 2, p sub 3, of course, this could keep going depending on how many terms you're supposed to have. Those are going to be numbers you get off of what's called Pascal's triangle, so I'll show you those in just a minute. You're also going to have to know A and B. A is always going to be whatever your first term is. B is always going to be what your second term is, okay? And once you see how this pattern works, you'll probably just get used to it and just remember how to do it really without having to refer to this too much, okay? But I'm going to talk you through that part of it as we go through this first example. Okay, this is what's called Pascal's triangle, and I'm not going to make you copy all of this down, so just listen carefully and I'll tell you like how much you need to copy. And don't worry about the fact that they have, you know, little hexagons. You just need the numbers, okay? So like when you're copying this in your notes, just put a 1 and then put a 1 and a 1 and then a 1, 2, 1, okay? So just make your rows of numbers when you put those in your notes. Don't worry about the fact that there's colors. Don't worry about the fact that they've got hexagons around them, okay? Now, if you will, I would say let's carry it down. Let me mark it with a red marker here. Let's go down to here. You're actually not going to have any problems that's actually going to carry you past this right here. So if you'll just copy these numbers down to this red line, then you'll be fine. Now, one thing you do need to remember about Pascal's triangle, and you need to copy this down, this is referred to as row 1. So when we start looking for rows, and I say, okay, we need row 4, you've got to remember you don't start counting with 1 like you would typically count something. So this is row 0, 1, 2, 3, 4, 5, 6, 7, and so on, okay? So you can just, you know, pause your video or whatever and get this copied down. Okay, the first example that we're going to look at, I'm actually only going to do just a third power here, just to kind of give us a short one, just so you'll kind of see how it works, and then we can go up to a larger power. Now, what you need to do is identify the parts, okay? So, start with n. So, as I told you, n is going to be your exponent, so that's going to be a 3. Okay, a is going to be your first term, which my first term just happens to be an x. B is going to be the second term, which is a -5. Okay, now the other piece of information is I'm going to write down the numbers off of Pascal's triangle that you're going to need for this particular problem. Since this is a third power, this is how this is going to work. So since it was a third power, you're going to need the numbers off of row 3. So remember, this would be row 0, 1, 2, 3. So off of row 3, I have a 1, 3, 3, 1. Okay, so over here I'm just going to write 1, 3, 3, and 1. Okay, so that's all the things that I'm going to need to work this out. Okay. Okay, I'm going to write this formula up here so I can, or fold it and put it up here so I can point at it as we go. Okay, so you notice the P sub 0, P sub 1, P sub 2, P sub 3. Like I said, those are going to represent these numbers. So this one, like the first one, would actually be P sub 0. P sub 1 would be the 3. P sub 2 is going to be this 3. And P sub 3 is going to be the 1. So actually, this particular problem will be finished once we get to this term right here, okay? I've got the ... because when you make a larger power, you're actually going to have more terms, okay? So I need to start out with the first number off of Pascal's triangle, which is going to be the 1. Okay, then I need to take whatever x is and raise it to the nth power. Or take what a is and raise it to the nth power. Well, a is x, and then I need to raise it to the nth power. Okay, put a plus sign. Okay, P sub 2 is just going to be the next number from Pascal's triangle, which is the 3 that we have over here. Okay, now you're going to take the a again, which is x. But this time you're going to do n minus 1. Now remember, n is 3, so 3 minus 1 is going to give us 2. Now this is where b starts coming in to the problem. So this is just b to the first power. Like that's just understood to be a first power. So b is a -5. Now all of this is being multiplied together. This p sub 1 times a to the n minus 1 times b. So all that's being multiplied. So when I put in my -5, I'm just going to put it in parentheses just to indicate the multiplication. Okay? All right, plus sign. So now we need the next number off of Pascal's triangle, which is also a 3. Okay, so then your a, which is an x. So this time you're going to do n minus 2. Well, again, for this problem, n is 3. So 3 minus 2 is 1. And now b would go up to the second power. So that means the -5 will now be a second power. Okay, plus sign. And next number from Pascal's triangle, that's going to be this last number right here, this 1. Okay, now here I have a to the n minus 3. So again, n happens to be 3, so 3 minus 3 is actually just going to give me a 0 power. And actually, once you get to a 0 power, you don't actually have to write that down, and I'll explain that again in just a minute. And now b is going to go up to the third power. So again, b is -5, and this goes up to a third power. Now, I want you to look at the pattern. Look what has happened. Okay, so look at what happens to what they refer to as a, in this case, x. You have third power, second power, first power, 0 power. So what happens is you start out with your a and raise it to whatever power is necessary for the problem. But then as you work it, it's just going to keep going down 1. So third power, second power, first power. But like I said, actually once you get to this where it says 0 power, there's really not even a need for you to even write that in there once you get it down to a 0 power, okay? Now, look what happened to B. Now, B happens to be the -5, okay? So the -5 right here is understood to be to the first power. So it goes up. First power, second power, third power. Now the reason why you didn't have -5 right here is because it's actually understood to be to the 0 power. So you remember how this one ended to the 0 power? Your B actually is here, it's just to the 0 power. So that's why we don't bother writing it. So it's like your B is to the 0 power, first power, second power, third power. So A goes down in power and B is going to go up in power, okay? Now you do need to do some calculations to finish this off, like do the necessary multiplying. Now here you could just write this as x to the third. So when I say multiply, that means you need to do the 3 times the -5. So that's going to give us a -15x to the second. Now this would be 3 times -5 squared. So if you do 3 times -5 squared, you're going to get a positive 75. Of course, the x there is to the first power. Of course, here I told you, if it's a 0 power, it's like it's not even there, so you don't even have to write it. So this is just 1 times -5 to the third. That's going to be -125. This is your final answer, okay?